Hello guys, welcome to Juvenile Gurukul. Hope you guys are doing well. As your examination is knocking at the door, so to boost up your preparation, today we are going to solve the sample paper released by CBSE. We are going to solve the physics part. Okay, so the first question. Which of the following mirror is used by a dentist to examine a small cavity in a patient's teeth? So first option is concave mirror, convex mirror, then plane mirror, then concave mirror, then any spherical mirror. Okay, so you know uh, in a concave mirror, what happens is that say this is the principal axis, this is the focus, and this is the pole. So when an object is kept between the focus and the pole, it produces a virtually magnified image. So as it produces virtually magnified image, so a concave mirror is used by a dentist to examine a small cavity, to magnify it. So the correct answer is option C, that is concave mirror. So this is our first question. Okay. Now moving on to the next question, we have which diagram shows image formation of an object on a screen by a converging lens? Okay, so the first option, here's the lens, and this ray is traveling parallel to the principal axis, and after getting refracted, it passes through this point. Now here it is written 2 into focal length. We know that r is equal to 2f, where r is the radius of curvature and f is the focal length. So here this is the center of curvature, but we know that when a ray travels parallel to the principal axis, it passes through the focus, not its center of curvature. So this option is not correct. Moving on to the next option, here the same flaw is there. The first this ray, after traveling through parallel to the principal axis, passes through the center of curvature. So this is not correct. Option C, so here you can see that the ray, after traveling parallel to the principal axis, passes through the focus region, focal length. Again, the second ray, after passing through the optical center, it passes undeviatedly, and it meets, the two rays meet at the screen. So this option is right. So this is our correct option. In the fourth option, you can see that this ray, after traveling parallel to the principal axis, it passes through the focus. This ray is correct, but the second ray, after getting refracted, it travels again through the focus. It should have traveled parallel to the principal axis. So this option is also not correct. Okay. Moving on to next question, we have which of the following can make a parallel beam of light when light from a point source is incident on it? First option, concave mirror as well as convex lens, convex mirror as well as concave lens, two plane mirrors placed at 90 degrees to each other, concave mirror as well as concave lens. Now in a concave mirror here, when a ray passes through the focus, after getting reflected, it travels parallel to the principal axis. Okay. Again, in case of a convex lens, when a ray is coming out from the focus, it travels parallel to the principal axis. So, question is given: which of the following can make parallel beam of light when light from a point source is incident? Here is a point source, and light is the emerging rays are parallel to the principal axis. So this is a concave mirror, and this is a convex lens. So our correct answer is option A. Okay. So next question. Consider these indices of refraction: glass 1.52, air 1.0003, water 1.333. Okay. Based on the refractive indices of three materials, arrange the speed of light through them in decreasing order. Now we know the formula that refractive index of a certain medium with respect to air equals speed of light in air by velocity of light in that particular medium. So refractive index is inversely proportional to the velocity of light in that particular medium. So more the refractive index and less the velocity of light in that particular medium. So here glass is 1.52, air is 1.0003, air is 1.0003, water is 1.333. So the correct answer will be speed of light in air should be greater because it has the least refractive index. So speed of light in air is greater than speed of light in water, then speed of light in water, then speed of light in glass. So the correct answer must be option C. Moving on to next question. If a beam of red light and a beam of violet light are incident at the same angle on the inclined surface of a prism from air medium and produce angles of refraction R and V respectively, which of the following is correct? So we have a prism. Okay. So so this is red light. So we know that refractive index for red light, speed of light in air, or it can be written as C divided by speed of red light in that particular medium. For here it is glass. Same for violet light, it's c divided by velocity of violet light in glass. Okay, so for red light, sine of angle of incidence divided by sine of angle of refraction. Here it is r, so equals mu of red, and sine of angle of incidence by sine of angle of refraction for violet, here it is v, is equal to mu. Now আমরা জানি যে v equals n lambda. Here v is velocity, n is frequency, and lambda is wavelength. Okay, now frequency is fixed. Now for red light, wavelength is more. For red, wavelength is more, and for violet, the wavelength is less. Clearly, velocity of red light in glass is greater than velocity of violet. Okay, so clearly from here we can say that mu of violet is greater than mu of red. Okay, so from here it can be deduced that v is also greater than r. So our correct option must be option D. Okay, so moving on to the next question, that is question number 22. Examine the above figure and state which of the following option is correct. One small box in the figure is equal to 1 centimeter. So here it is the object, it is kept at the center of curvature, it is C, and F is focus, and it's a P. So here one small box is equal to 1 centimeter. So here one small box, two small box, three small box, four small box, five small box, six small boxes. So 6 small boxes are there. So it must be 6 centimeter. Okay, so we know that r equals to 2f. Here r equals to 6 centimeter. So f must be 3 centimeter. Okay, so the mirror has a focal length of it's as all distances are measured from the pole. So as the object is kept at the left side of the pole, so it must be negative. So f must be minus 3 centimeter according to sign conventions. So, and as the object is kept at the center of curvature, so we know that when an object is kept at the center of curvature, the height of the image produced is same as that of the object. So but as it is a concave mirror, it must be an inverted image, so the magnification must be -1. So our correct option is option B. moving on to next question. Here the angle of incidence from glass to wire at the point O on a hemispherical glass slab. It is a hemispherical glass slab. So here you can see that it is the angle of incidence. Okay. Now as it is a hemisphere, we can consider this is a circle. So here it is the tangent at the point O. Now as this ray is along the radius, so this must be 90 degree. That means the angle of incidence here is 0 degree, because the ray is incident to this surface along the normal. So here the angle of incidence must be 0 degree. So the correct answer is option B. Moving on to next question. Okay. A prism ABC with base BC with base BC is placed in different orientations. A narrow beam of white light is incident on the prism as shown in below figure. In which of the following diagrams, after dispersion, the third color from the top of the spectrum corresponds to the color of the sky? Okay, so this is a prism. So this is white light, and after getting refracted through this prism, when it comes out, the least scattered light ray is the red light, and the most scattered, it's not scattered, it's dispersed. The correct word is dispersed. The most dispersed light is violet, as it has the least wavelength. So here it is written, then violet, then we have indigo, then blue, then green, then yellow, then orange, then red. Vibgyor. Okay. So in which of the following diagrams, after the third color from the top is spectrum? Third color from the top, but here blue is from the below, so option 1 is not correct. So if we reverse this, it becomes option number 2. If we reverse the diagram, see, blue is on from in the third place from the top is the blue. So our correct option must be option B, that is this diagram. So next question. If the power of a lens is -4 diopter, then it means that the lens is a. Now, first of all, let me tell you that negative focal length means it is a concave lens. Now, when focal length is negative, it is a concave lens. In case of lens, okay, this word is important. In case of lens, it is concave. Okay, so this is clear that the correct answer must be option C or must be option A. Now we know that power equals to 100 by f in centimeter. So power equals here, so power is -4 equals 100 by f, or f equals -25 centimeter. Okay, so our correct option is concave lens of focal length -25 centimeter. That is option C. So moving on to next question, question number 40. Rays from sun converge at a point 15 centimeter in front of a concave mirror. Where should an object be placed so that size of its image is equal to size of the object? Okay, so this is the sun, and rays coming from the sun is assumed to be coming from an infinity, so they are parallel to the principal axis. So after getting reflected, they will converge at the focus. Now it is said that it is converged at a point 15 centimeter. So in front of the concave mirror, this is the pole, so the focal length must be -15 centimeter. Okay, now we know that r is equal to 2f, where r is the radius of curvature. So here putting f is equal to -15 centimeter, you get r is equal to -30 centimeter. Now it is said that where should an object be placed so that size of its image is equal to size of the object. Now we know that when an object is placed at the center of curvature of the mirror, the image formed has the size equal to that of the object. So the object must be placed 30 centimeter in front of the mirror, that is at the center of curvature. So our correct answer must be option A. Okay. Moving on to next question. If the real image of a candle flame formed by a lens is 3 times the size of the flame and the distance between lens and image is 80 centimeter, what distance should the candle be placed from the lens? Now we have real image of the candle flame formed by the lens is 3 times the size of the flame. Now we know that magnification m is equal to h of image by h of object. H means height. Here it is 3. Magnification is 3. Okay. Now we have image distance v equals to 80 centimeter. Okay, again we know that m equals to v by u, where u is the object distance. Okay, now there must be a minus sign, because magnification equals to minus of height of image by height of object, because it is inverted, it is -3, or -3 equals v is 80 and u. Okay, so or q equals to 80 by -3, and therefore u equals to -80 by 3 centimeter. Okay, so our correct option must be option D. Okay. Next question. Okay, here we have a diagram. Okay, this is the principal axis. Okay, object is here. See, this is the center of curvature, and it is the focus. Okay, while looking at the above diagram, Nalini concluded the following: the image of the object will be virtual one. The reflected ray will travel along the same path as the incident ray but in opposite direction. The image of the object will be inverted. This is a concave mirror and hence the focal length will be negative. Okay, which of the following statements are correct? Okay, so option, let's say statement number 1, the image of the object will be virtual one. Now it is a concave mirror, and we know that a concave mirror produces only virtual image when the object is kept between the focus and the pole. So option 1 is not correct. Sorry, statement 1 is not correct. No, statement 2, the reflected ray will travel along the same path as the incident ray but in opposite direction. Okay, so here it will follow law of reflection here. So you can see it is along the radius and it is the tangent here. So here angle of incidence is 0 degree, so angle of reflection must be also 0 degree, so it will travel along the same path. So this is correct. Now statement 3, the image of the object will be inverted. Okay, so image must be inverted when it's kept between the center and focus, center of curvature and the focus, because it's a concave mirror. So it is also correct. Option, statement 4, this is a concave mirror. Yeah, you can see this is a concave mirror. See, and hence the focal length will be negative. So focus is there and pole is there, so it is on the left side of the pole, so it is also negative, so it is correct. So statement 2, 3, 4 are correct. So the correct option to this question must be option C. Okay. Okay, moving on to next question, question number 45. Here we have one medium, we have another medium, and then we have back medium number 1. Okay, so the question is, in the above diagram, light is traveling through different media. It is noted by a scientist that angle 1 equals to angle 3 equals to angle 4, but angle 2 is less than angle 1. Which of the following statement would be correct? Now আমাদের এখানে medium 1 এ we have angle of incidence is 1 and angle of refraction is 2. Now আমরা লিখতে পারি refractive index of 2 with respect to 1 equals sine of angle of incidence, that is here 1 angle 1 by sine of angle of refraction 2. Now 2 with respect to 3, similar way we can write. Now here you can see this line and this line are parallel, so angle 2 must be equal to this angle must be angle 2. These are alternate interior angles. Okay, so refractive index of 3 with respect to 2 equals angle 2 by angle 3. Okay, now 3 with respect to 1, 3 with respect to 1. Again here you can clearly see that this line and this line are parallel, so angle 3 must be equal to angle 4. Okay, so angle 3 equals to angle 4. These are alternate interior angles. Now equals again we are also given this thing, angle 3 equals to angle 4, so equals to sine of angle of incidence, that is angle 4 by sine of angle of 4. So these things are equal, so it is equal to, okay, 1. Okay, now statement 1. So here you can see that in medium 3 the angle of incidence and the angle of refraction in medium 1 is 4, so they both are equal, so we can conclude that medium 3 and medium 1 are same. So in option number D you can see that medium 3 and medium 1 are essentially same medium, but medium 2 is denser than 1, because you can see that angle of refraction is less than the angle of incidence, so option number D must be correct. Okay, so far so good. Moving on to next question, we have the refractive index of flint glass. Okay, refractive index of flint glass, okay, equals 1.65, and that for alcohol, the refractive index of alcohol 1.36. both are with respect to air. What is the refractive index of flint glass with respect to alcohol? We have to find refractive index of flint glass with respect to alcohol. Okay, this must be equal to refractive index of, okay, we have flint glass divided by refractive index of alcohol. Okay, here we are given is 1.65 divided by 1.36. So if we calculate this thing, we'll get 1.21. So our correct option must be option B. Okay, so moving on to next question, we have a ray diagram here. Now here it is says the above lens has a focal length of 10 cm. The object of height 2 mm is placed at the distance of 5 cm from the pole. Find the height of the image. So here f is 10 cm, u, that is object distance, is minus 5 cm. It is placed in front of the lens, and the height of the object is 2 mm. Now using lens formula, have 1 by f equals 1 by v minus 1 by 5. This, or here we have f is equal to 10 centimeter. 1 by 10 equals to 1 by v. This is minus plus 1 by 5, or 1 by v equals 1 by 10 minus 1 by 5 equals to 10, 1 minus 2. Therefore v equals to minus 10 centimeter. Okay, now we know that magnification m equals v by u. Okay, so it equals minus 10 by minus 5. It must be equal to height of image by height of object, that is 0.2, and it is millimeter, so convert it in centimeter, you get 0.2 centimeter. So here we get h2 equals to 0.4 centimeter. The correct answer must be, it is equal to 4 millimeter. The correct option must be option C, that is 4 millimeter. Okay, moving on to next question, we have a cable manufacturing unit tested few elements on the basis of their physical properties. Okay, so here we have properties W, X, Y and Z. Okay, so malleable, W is yes, ductile yes, electric conductivity yes, melting point high. Okay, so malleable for Y, X is no, electric conductivity yes, melting point is low. Again Y, it is malleable is no, ductile no, electric conductivity yes, melting point no, low. For Z, malleable yes, ductile yes, electrical conductivity yes, melting point is high. Okay, so which of the four are discarded by the company? So in here you can see that in X, Y and Z, the X and Y are not malleable, not ductile, and Z does not have any electrical conductivity. So it is clearly বলা যেতে পারে যে X and Y and Z must be discarded by the company. So the correct option is option number B. Okay, moving on to next question. We have a case here. Okay, Noor, a young student, was trying to demonstrate some properties of light in her science project. She kept X inside the box as shown in the figure. With the help of a laser pointer, made light rays pass through the holes on one side of the box. She had a small butter paper screen so to see the spots of light being casted as they emerged. Okay, this is the case and we have the diagram here. Now the first question is what could be the X she placed inside the box to make the rays behave as shown here. So here this is the X that is kept here. Okay, here you can see that these rays and these rays have become laterally shifted. Okay, this must have gone through this, but it has laterally shifted. So this happens in the case of a parallel sided glass block. We can lateral shift happens in the glass lamp. So the correct option must be option number B, that is a parallel sided glass block. Okay, moving on to the next question, we have for the same case, she measured the angles of incidence for both the rays on the left side of the box to be 48.6 degree. She knew the refractive index of material X inside the box was 1.5. What will be the approximate value of angle of refraction? So she measured angle of incidence for both rays on the left side of the box to be 40 degree. This is 48.6. Now we have angle of incidence is I equals 48.6 degree. Here you can see that Q we have mu, refractive index of glass with respect to air is 1.5. Okay, so what will be the approximate value of refraction? Okay, so we know that sine of angle of incidence by sine of angle of refraction equals to mu, or sine of 48.6 degree divided by sine of r equals to 1.5. Okay, now here we can see that sine 48.6 is given 0.75. okay, so 0.75 divided by sine of r equals 1.5. okay, now or sine of r equals 0.75 divided by 1.5. okay, or sine of r equals 0.5. okay, now to find r we have to take inverse. I think this is not in your syllabus, so I'm giving a bit hint. If sine of some angle, say a, equals to x, now to find a we take inverse like this: a equals sine inverse x. okay, now you can also use some tricks like sine of r equals 0.5 is half. Now we know that sine 30 degree equals to half, so here r must be equal to 30 degree. So angle of refraction is 30 degree, that is option C is correct. Moving on to next question, that is for the same this case. Okay, her friend noted the following observations from this demonstration: glass is optically rarer than air. This is not correct. Air and glass allow light to pass through them with the same velocity. This is also not correct because they have different refractive indices. Air is optically rarer than glass. This is correct because refractive index of glass is more than that of air. Speed of light through denser medium is faster than that of rarer medium. This is also not correct. The ratio of sine of angle of incidence in the first medium to the sine of angle of refraction in the second medium gives the refractive index of the second material with respect to first one. This is also correct. So which of the following is correct? So we have option statement 3 and statement 5. So statement 3 and statement 5. Option number D is correct. Okay. Now moving on to the next question, we we have, if the object inside the box was made of material with a refracting index less than 1.5, then the lateral shift would be less. This is must be done because in glass lab, when the the refractive index is less, it is less shifted. So this is the correct answer. So option A is correct. I'm going to solve the questions that were for the visually impaired candidates. Okay, so the first question: if a virtual erect and enlarged image is formed by a lens, then which of the following options are correct? It is a concave lens and the object is placed between pole and focus. It is a convex lens and the object is placed between focus and center of curvature. Option C: it is a convex lens and the object is placed between pole and focus. And option D: it is a concave lens and the object is placed between focus and center of curvature. Okay, as you can see, it is a virtual erect enlarged image is formed by a lens. So which of the following option are correct? So it must be, you can see when it is a convex lens, okay, and it is the focus and this is the pole, is kept here. A virtual is and enlarged, sorry, that's not this part. Okay. Say this is the ray parallel to the principal axis, so it will pass through the focus and will have passing through this one, so this will be formed. So here it is the image. So here you can say virtually enlarged image is formed. So the correct option must be option number C. Okay. Mirror will mirror is concave with 6 cm focal length. Object is placed as center of curvature. Which of the following options are correct? The mirror will produce an image of magnification plus 1.5. The mirror will produce an image of magnification minus 1. The mirror will produce an image of magnification plus 1. The mirror will produce an image of magnification minus 1.5. Okay, so we have to find the correct option. Which of the following options are correct? So okay, more than one option may be possible because options are correct anyway. So option number 1, let's see. The mirror will produce an image of magnification plus 1.5. okay, now here you can see the object is placed as center of curvature. When an object is placed at the center of curvature, you know that the magnification is, I mean, like the image, the height of image is equal to height of the object. Okay, so the magnification must be plus or minus 1. So option 1 is not correct. The mirror will produce an image of magnification minus 1. Okay, here see the mirror is concave, so this is correct. So the mirror will produce a magnification image of magnification plus 1. This is not possible because it is a concave. And on option D, the mirror will produce a magnification of minus 1.5. This is also, so option B is correct. Okay. Moving on to next question. Okay. If a ray passes from air to glass in a spherical glass slab and passes through the center of slab without deviation, then angle of incidence from air to glass at the point on the glass slab is, okay, if a ray passes from air in a spherical glass slab, okay, this is say spherical glass slab. So a ray passes from air to glass in a spherical glass and passes through the center of the slab undeviated. Okay, so passes from air to glass in a spherical and passes through the center of the slab without deviation. Okay, and without deviation, then angle of incidence from air to glass at the point of the glass slab. Okay, so it is clearly concluded that at the point of contact of glass and air, this must be traveling along the radius, okay, because it is said here without deviation. Now this is only possible when the ray is traveling along the radius of the spherical glass slab. So the angle of incidence must be 0 degree. So option number B. So moving on to next question. So moving on to next question. Okay. Out of all colors making the white light, which one will deviate the most while it passes through a prism? Now we know that wavelength of violet is the least, so it will deviate the most. So the correct option is option number B. Okay. Now moving on to next question. It is a case based problem. Okay. So Nalini draws a ray diagram for an object in front of a concave mirror. She draws a ray starting from the top, okay, of the object and falling on the mirror perpendicularly. Okay, the ray after reflection will pass through the holes. Okay, this is not our correct diagram, but this is the concave mirror, and here we have the object. Say this is the center of curvature. Now it is falling on the mirror perpendicularly, so this must pass through the center of curvature. This is C. So when this will pass through the center of curvature, here you can see angle of incidence is 0 degree because this is a tangent and it is along the radius, so radius and tangent are perpendicular, so angle of reflection must be 0 degree, so it will pass through the center of curvature. It's not correct. So this is not correct. So this is the correct answer. And this is also not correct. So the correct answer must be option C. Okay. Moving on to the next question, we have, if the refractive index of water with respect to air is 1.33 and that of glass with respect to air is 1.5, refractive index of water with respect to air is 1.33 and refractive index of glass with respect to air is 1.5, then what is optically denser than glass? This is not correct because glass has more refractive index, so this is not correct. Air is optically densest of all media. Air is the rarest. It's not correct. Okay. Air's optical density is between glass and air. Air's optical density is approximately 1. It is. So this is not correct. Glass is optically denser than water. This is correct because refractive index of glass is more than that of water. So this is correct. So option number D is correct. Okay. Moving on to next question. A convex lens has a focal length of 10 centimeter. Okay. The object of height 2 millimeter is placed at a distance of 5 centimeter from the pole. Find the height of the image. Okay. So focal length of convex lens is 10 centimeter. Object height is 2 millimeter, that is 0.2 centimeter, is placed at a distance u equals to from the pole minus 5 centimeter. Find the height of the image. Okay, height of the image inside of object. Now using lens formula, 1 by f equals to 1 by v minus 1 by u, or f is minus 10, 1 by v minus of minus 5, or v equals to 1 by 10 minus 1 by 5, or v equals to minus, sorry, this 1 by v equals to minus 10 centimeter. Okay. Now so therefore magnification, we have v by u equals h of image, h of object. So v equals to minus 10, u equals to minus 5, height of image is hi, height of object is 0.2 centimeter, so 2, so height of image is 0.4 centimeter. Okay, therefore height of image equals 4 millimeter. So the correct answer is option number C. Moving on to next question, we have a case here. In an experiment, Pooja used a equilateral triangular glass prism and projected a narrow beam of white light source from one side of the surface of the prism. She placed a screen on the other side and saw many colors appearing as patches on the screen. But when she used a red light source, she could see only a red patch on the screen. Similarly, she used a blue and green light and could see only one color on both occasions. Okay, here it is the case in order to find the questions, find the answers to these questions. So the phenomenon that she was trying to demonstrate, what is said is used equilateral triangular prism. Okay, so projected a narrow beam of white light, okay, white light, and she placed the screen on other side, so screen, okay, and so many colors, okay, here many colors will appear on the screen. But when she used when she used only red light, she could see only one color, Similar, when she used blue green light source, she could see only one color. So the phenomenon here she was trying to demonstrate was dispersion. Okay, so option A is correct. Moving on to next question, we have the reason why she could not see other color when red light was used, because red color does not refract in prism. So this is not possible. Red color is monochromatic. This is possible because in white light is composed of 7 other colors like violet. White light includes violet, indigo, blue, green, yellow, orange, red, 7 colors. So what happens in a prism is that when white light is incident on the glass prism, they have different wavelengths. Okay, so they travel at different velocities in the glass prism, so they get deviated in different angles. So that's why dispersion happens. So as red color is monochromatic, so she could see only one light in the screen. The prism was defective. This is not correct. Prism is opaque due to red color. This is not possible. So correct answer is option number B. Moving on to next question. Okay. Which of the following can be the correct explanation that Pooja can give to her friends to explain this phenomenon? Different lights travel faster in different prism at different rates. Any light could disperse in prism. Enough data is not possible. Different wavelength travel at different speeds in glass. So this is the correct, and this is not correct. This is not correct. This is I have also discussed previous here that different as they have different wavelength that travel at different velocities within the prism. So option D is the correct one. Okay. Moving on, last question. She could also relate to another natural phenomenon that we observe on a rainy, humid day as the rain comes out. What could be that phenomenon? So now, this is not correct. Option A we have lightning. Option B blueness of the sky. Option C rainbow. Option D scattering of light. Now, this is the prism, and when white light comes out, it disperses into several colors. Okay, disperses into several colors. So this happens only in case of rainbow. So the correct answer is option C. Option C is correct. Okay. So this is the end of our session. Hope you guys enjoy this video, and it will be very much helpful to your preparation. Thank you.